The plant model test suite concludes with the short circuit ratio ramp down tests. And like I said, this is an interesting one. We decrease the short circuit ratio at the point of connection with transitions between source impedance during faults at 5-second intervals. So remember the maximum short circuit ratio we could get was somewhere between 5 and 7, depending on the on which plant we're looking at, the solar or the wind. So we're not starting at 20, we're starting at 5 or 7. And this is the equivalent X at 230 kV to achieve that. So the plant reactance, to reiterate, the plant reactance is not close to 0, so it's at least 74 ohms. And so, to get a short circuit ratio of 10, we could have 52.9 ohms at the most. So we cannot get down to the up to the short circuit ratios of 10 and 20. But we can go. We can start from here, and we can steadily reduce the short circuit ratio down towards 1. We're expecting stable operation until we get around 2.5 or 2. We don't really expect it to be stable when we get down to a short circuit ratio of 1. And so the idea of the test is we start at time 0, and every 5 seconds we do a transition between these short circuit ratios. The way we do that is, so we start with the first test period, and we're actually running 10 seconds to make sure that the the model is stabilized. But our grid impedance is J.001 ohms, so it's a very strong grid, and it stays that way for 10 seconds. At 10 seconds, we put on a fault, and it's going to be cleared in 0.16 seconds. So what the IBR sees, the IBR is over here. The IBR sees this fault for 0.16 seconds, and so it is expected to ride through. It should ride through. But while the fault is on in the middle, so at 10.08 seconds, we commutate the current between the the 0.001 ohm reactance. This switch is going to open at 10.08 seconds, and then this switch here is going to close at 10.08 seconds. And it commutates the grid current from the very small reactive impedance up to this larger one. And so when the fault is cleared at 10.16 seconds, the IBR is reconnected to the grid. It doesn't see the J.001 ohms anymore. It sees this J31.47. And so that is a step change in the short circuit ratio. So it is an artificial test sequencing, but it is kind of an exploratory or informational test on how well the model is working and how good the control parameter settings are. One thing I should say, we didn't we set this up manually in a separate version of the circuit, so we just click the run button. It's not automated by scripting. So you'll see that in your tool specific examples to come next.